Good morning. This morning I'm going to be discussing with you the concept of earth-sheltered homes.
Some of our stuff may overlap because I'm doing underground.
Very likely, so there's a lot of interconnected concepts. The overall purpose of an earth-sheltered home is to take advantage of the high thermal mass of the earth. Soil has an R value between 0.25 and 0.5 per inch, and that is affected by the moisture content, compaction, various factors. In the long term, an earth-sheltered home has a very small footprint, because you are reestablishing the soil on top of the home for the most part. So our thermal mass advantage is especially prevalent in the summer. In the winter, it's going to cut down the amount that we have to heat the home. In this example, we see that on a -20 day in the winter, an earth home would only have to be heated about 30 degrees to get to a comfortable 70. And in the summertime, we would have to cool it 0. So that would be a huge energy saver. Some of the simple design concepts of an earth shelter home are some insulation, which can be very minimal depending on your climate and how complex you want to make the home. Ventilation, which is crucial, and utilizing passive heat through a lot of the passive design concepts that were discussed Monday. So when I say air circulation is crucial, it means very, very crucial. You can do this via natural air circulation by either just having some sort of vent, and the stack effect will naturally circulate air through the house. This can be climate dependent on whether you want to utilize that or not. Most of the modern earth shelter homes that I saw did have a mechanical air circulation, at least as a backup. And that can be just some kind of exhaust fan with a flap or something that can close for the weather. The reason the air circulation is so important is not only for mold, but also for things like carbon dioxide and monoxide and any other things like that. You can't just open a window if you're back here in the bedroom. Right, so our passive solar concept, I'll just cover very briefly since we had such a great detailed presentation of that Monday. So utilizing the passive solar concepts, we're going to retain less heat in the summertime via the south-facing windows being at the proper angle, all those concepts. But we're also going to retain more heat in the wintertime by taking advantage of that solar energy that comes into the house. It will heat up our thermal mass and help keep the house warm in addition to the thermal mass of the earth. So even less heating costs. So our types. We have underground and bermed. A lot of the pictures that you're going to see in my presentation are somewhat of a hybrid. Basically, underground refers to the mass majority of the house being, subterranean, covered up. You'll have one main fenestration, couple of windows, things like that. Bermed is more this top picture where the house is kind of built into the side of the bank. So they're taking advantage of that thermal mass, but they're not really encompassing the whole structure into the earth. So earth shelter homes have been around for quite some time. Here's an example of a traditional underground home. This helps maintain consistent temperatures, but it's also what they had on hand. A lot of places, especially in my time in the Middle East, all the places that I saw out in the rural areas, if they weren't completely subterranean for a cellar, the homes at least had 3 to 4 steps once you went through the door down to the main level, and that kept helped keep it warm in the wintertime, but also um, considerably cooler during the summer months. Here's an example of a traditional berm. You see these a lot in like the Southwest, um, places that aren't quite as hot as some of your, desert areas, but um, still very arid. Um, this allows for a lot of airflow through the house, just taking advantage again of that thermal mass and protection from the elements by kind of building into the bank hillside. On the other spectrum, a lot of traditional Northern European homes in Scandinavia and Norway, especially in the far uh, northern longitudes, they would build these semi-traditional houses and utilize the earth as a roof, and also for that thermal mass. This would give them very good protection from the elements, from the cold, and it's kind of an ideal climate for this because of how sporadic the weather can be. Here's a nice example of a longhouse that is earth sheltered. And so you can see our stacks here for our nice ventilation. And this would be a perfect house for a large family, or for, the whole village to come into during extreme weather. So some of our modern incarnations, they utilize a lot of renewable tech. Obviously, people that are going for earth shelter homes have done some research on sustainability. So you see a lot of passive solar design, PV system utilization, water recycling, um, all sorts of systems. Um, they generally use high efficiency utilities. And a great thing about earth shelter homes is the HVAC systems. If they choose to have them, they can usually get a much smaller system than a traditional home would require for the amount of square footage, just because they don't really have the heating and cooling needs that a normal house has. All right, so our general construction of a modern uh, earth shelter house, most of the time they're built out of reinforced concrete. Some of them are poured in place. There are a lot of prefab uh, options. The main thing that they're looking for is a structure that's strong enough to hold up to the weight of the earth, and also something that they can mitigate water around, so you don't have any leak issues. Um, Here again is just another picture. This was quite a big excavation on the right, and you can see those forms where they've poured the concrete in place. And concrete is kind of the go-to in modern applications because of its high thermal mass properties. All right, so reinforcement. I found a lot of interesting reinforcement methods. Uh, Several houses will use old tires as their kind of main embankment support, and there's a lot of different advantages of this. For one, it's recycling a material that is not recyclable otherwise, or if it is, it's a high energy recycling. But the tires actually work really well because not only their weight and the high friction of the material helps hold them in place, but because they're hollowed out, it also allows for water runoff to kind of come down through the tires. So it's kind of a two-in-one. They don't have to go back and put a waterproof membrane on the back of this. Uh, in other situations, they'll use just like a Tyvek type bag and fill it with earth, and they'll use those as reinforcements. And it's just a means of kind of keeping the fill dirt in place, keeping it from, naturally sloping and degrading over time with water. So these are really cool, and it's a new movement that's come about, is the modular pods, prefabs for underground houses. They come in all different shapes and configurations. You can do, a small couple hundred square feet, or there are some that are a couple thousand square feet. It's pretty limitless on what you can do with these things. I saw there was a couple of different composite materials that they used to make these, some with recycled plastics. Um, I just found these to be really cool because of how customizable it is, and it lowers the cost because you're not having to pay an architect to get the whole house design. These things are already pre-approved and engineer stamped. So a big advantage of underground or shelter houses is the eco-friendliness of them. You have the initial footprint of the excavation, but then generally the footprint of the actual structure becomes much smaller, and then you're able to rebuild that soil on the top, which adds to our carbon sequestration. You're not going to have trees on top of your house, but you can have a lot of plants and just kind of maintain the natural landscape. This is a very cool house by a Northern European architect. Um, and as you can see, it's very well hidden from all sides except for the very front. They actually had to put this fence around the top of the structure to keep cows from walking in. Um, just another great example of how cool and modern earth shelter houses can be these days. So here's an example of a unobstructed landscape, maintaining this field and having a nice house tucked back in there. This was a very cool modern earth shelter house I found. It's another example of the kind of hybrid between berm and underground, although I'd say it is primarily a berm. Um, and as you can see, they've got that grass and just the natural roughage on the roof. So it's got that good soil, it's sequestering carbon, it's helping with the water runoff by those plants absorbing the water, just all kinds of benefits. So the main advantages of an earth shelter house are the high thermal mass, which obviously is gonna, make your house super efficient, um, make your passive solar more efficient, um, just all kind of benefits. Protection from the elements, extreme heat, extreme cold. Your earth shelter house is not going to be blown over by a tornado. If you do have a fire, um, unfortunately, in your earth shelter house, it's not going to bring the structure down. You may lose some of your internal cosmetic work, but the structure itself um, is pretty much impermeable to that. Uh, and the biggest advantage is your lower energy needs. So barely anything to cool the place down in the summer due to the stack effect and the natural consistent temperatures of the earth. And in the on the other end, in the wintertime, again, using the natural consistent temperatures of the earth, you won't have to heat it as much. So disadvantages, the initial excavation costs are going to be considerably higher than building a, traditional foundation house. You're not going to be digging down a couple of feet. You're going to be digging down several feet. So those costs add up a lot more. You're going to have more moisture issues that you're going to have to contend with. But again, a lot of those can be mitigated via proper construction. This is an example of an technically an earth shelter house that I personally find pretty boring and bland. If you were gonna build an earth shelter house, you might as well make it semi-unique and not just look like it's a normal craftsman house, whatever you want to call it, tucked into a bank. So our overall cost, as I kind of discussed, your excavation, your waterproofing is going to be another significant initial cost because you're going to be waterproofing the entirety of your structure or the majority of your structure, whereas a normal structure, as far as waterproofing masonry, you're just looking at like your foundation. As far as materials, most of the research that I found said that general materials beyond concrete are actually less than a traditional house. That again is dependent on how you want to construct the inside of the house. If you're fine with just having concrete walls, which can be painted or textured, um, that's much cheaper. But some people do choose to put up stud walls and drywall and do the whole shebang. There is a lot of back and forth on whether you should do that because of the inherent moisture problems that can happen. But that's again the builder's preference. And then lastly, labor, just like any other construction site. All right. So in conclusion, my assessment of Earthshelter homes is that the higher costs are definitely worth it. They are very efficient and they're Tolkien friendly.
Well, we have a lot of shared images there. I recognize about half of what you put in yours.
Hmm.
But
Well, I went first, so I think technically you're plagiarizing.
no, my first half of mine's a different approach. You did more of a technical presentation. Mine first half is more historical. I think I'll pull out okay.
You'll be fine, I'm sure.
Initially, I got a couple of questions. How do they get the dirt to stay up here? Or excuse me, the soil. How do they get the soil to stay up here?
That's a very, very good question. I think on these, I'm not sure if you can see my mouse or not, but the soil actually will get kind of filled in all the way around. You see those triangular shapes
Yeah.
on each side of the fenestration. So I think all of that space gets filled in.
I tell you, as much rain as we've had, I'm looking out at my yard, and my yard is ending up in my neighbor's yard. I mean, we've just got so much runoff. I'm just, that was one of the first things that kind of hit me. That one is a really beautiful one. This one here. So does a living roof, just a house with a living roof, is that considered earth sheltering?
I wouldn't consider just like if it was a freestanding structure with a living roof. I wouldn't consider that an earth shelter home necessarily. Sort of, it's utilizing the concept for that thermal mass on the roof.
Right.
But I think unless it's like partially subterranean, I wouldn't consider it a full earth shelter.
Yeah.
There's a fine line between actually some of my stuff is earth sheltered. There's a fine line between actually earth sheltered and underground. So it's half dozen of another.
Yeah, for sure.
This is probably something you wouldn't want to build in California, right? Where it's earthquake prone.
No.
That
was another disadvantage I wanted to mention was if you did have damage from like earthquakes, then that can be a costly repair.
Yeah, it seemed like that might be almost detrimental to the whole thing.
Mm-hmm.
I like I say, I love this image. I like the whole idea. My concern here is all those trees growing across the top of it. Trees can be they can be detrimental. I mean, heck, I had a friend who had I want to say it was a maple beside of his house, and it started cracking the basement wall. So we went over and we was all helping him work on repairing that crack. So we had to, support the house and take off the back wall a little bit. I guess we should have went in there and probably dug down outside, but we went inside and started working. So when we were taking that wall down, when he pulled one particular block out of place, and the root had so much pressure against the wall that it came back and knocked him about 10 feet back on his butt.
Yeah, I could see that. They're probably eventually those trees will definitely be a problem on that. That one kind of looks like a little do-it-yourselfer project.
Yeah. One thing to note here, I like this. This is a fresh air vent for the fireplace. So that you had said that ventilation was a huge thing, and it is. Probably the two biggest things there, or three, I guess three. The biggest things is proper support, ventilation, and then water. I mean, because you really gotta big time pay attention to getting all of these places sealed up.
Mm-hmm.
What do you think these are?
Yeah, I was looking at that. I feel like I don't know if they're storage or if they're just some kind of ventilation chute of sorts. I wasn't really sure.
I didn't see any images like that when I was searching. That looks like it might be ventilation though.
Or maybe even like a water catchment.
Yeah. I'm wondering if it's kind of a passive solar thing where you have like underground water that helps with thermal mass a little bit more. You bring the water up front, grab the solar, takes it back down and keeps it warm storage underneath. I don't know. I thought that was interesting when I seen that.
Yeah.
It does look more like air ventilation to me, with the same sort of passive ventilation systems we were looking at before.
Danny, can you turn your microphone up a little bit? Or I heard about half of that.
Sorry if I was quiet there. It does seem more like air ventilation.
Okay. Yeah, that's what I'm.
On that, yeah. And considering you'd want more ventilation for the earth berming.
Right. I kind of agree with you there. That's kind of bland. Almost looks like just, a traditional house stuck back in the ground. I'm like you.
Yeah.
Any other questions, comments?
Yeah. I had to put that one in there because it was so bad.
When I was in architecture school, I designed a house similar to this. It didn't have these wraparound things here, but it was basically a house on a ski slope, and so we were given, detrimental problems. The assignment was, one person had to design a house, an earthquake prone area. Another person had to design a house in a tornado area. Mine was avalanche. And so I dug it back into the ground here pretty much, this way. But like I say, it didn't have these curves on it. These mine kind of just came out straight. And a couple of things that we had to do. We had the main entrance here, but we had emergency entrances up above. So it was actually a tower that went way up above. So if they had avalanches, that had other means of getting out and so forth.
I'd hate to have to snow shovel out that patio right there.
Yeah.
4 or 5 feet of snow. That'd be a rough
Yeah.
way to get out in the morning.
Absolutely.
Any idea where that one's at, Mark?
It's been, like a week and a half since I looked at it. I think it was in Northern Europe, I believe.
Okay.
There is one house, or the remnants of a house in Northern Europe that ranked way up, as being close to one of the oldest structures. And it was like way the heck up here somewhere. I mean, it's like super cold, and it was mostly underground. I don't remember which town it was, but somewhere up here there was remnants of one of the oldest shelters that still had remnants of it, and it was underground, and so they had used the stones around there and what wood and covered it up, and then somehow got this earth to stay up there. And I thought that was really cool because they dated it like 9,000-10,000 years, so it was pretty cool on that.
But the root systems from just like the grass and stuff.
Yeah, I
very
guess
much
so. Yeah,
give
yeah,
it-
right.
give it structure.
When you say just now, when you said root system, it made me think that, going back to this other picture here, if you had a root system up here, but you were able to maintain these trees, had some sort of plant that would not, that wouldn't get much bigger than this, then that root system could also help hold that dirt. And what makes me think is those pictures of Indiana Jones where they're going into that, what is it, Mayan? Let's see if I, Mayan temple. When you get down there and you see all those roots that are growing up all over it. And of course, I'm never going to find a good picture of what I'm wanting to show you, but you know what I'm talking about? Those the root systems that pretty much just take over these old temples.
Oh yeah.
You're thinking more like Angkor Wat.
What is it?
Cambodia, Angkor Wat, ANG. Yeah, just Cambodia temple will probably get you there.
Yeah.
There you go.
Mhm.
Look at those old roots.
And it's amazing that these things grow, and well, I guess it's because they're all made of stone, but they don't. It's still there,
Mhm.
So that's pretty cool. Any more questions for Mark? Thank you, Mark.
Well, I don't know, Mark. Just throwing in. Did you see anything else on as far as dealing with exterior bulk water? We looked at several products like our drainage mats, things like that. Did you see any other examples of ways to deal with bulk groundwater?
Not bulk. It was a lot of traditional systems, drainage mats, and but on a larger scale, like the whole thing drainage mat. But a lot of the houses I looked at did catchment systems
Right.
to help alleviate that.
That's what I've seen. Really, is just kind of a larger versions of the drainage maintenance systems that we have on traditional foundations. But I have seen some pretty over-engineered systems for that, but I feel like it's always going to be worthwhile to spend the money on the upfront
Yeah.
than deal with
There was one house in your presentation that I watched a whole video about that had the angled windows, and that was an Earthshelter house, and he recycled all of his water, and it fed that whole little front greenhouse area. It was all recycled.
Yeah, I just with this amount of concrete underground, you really have to take a lot of major steps to reduce the hydrostatic pressure on the walls and deal with the fact that it's going to see a lot of moisture.
Yeah.
I had one friend who had a earth bermed house and their garden was on top and they watered the garden all the time. So it's like you're just pouring water on your house constantly.
I found that, when you got gardens on places like that, it's like that whole structure will suck the water out of it. I mean, you got a garden on top of a house where you may not have, maybe 2 feet of dirt or something, even less, but man, that water just goes. And so you're having to water it twice as much.
Mm-hmm. Unless you do like a gray water irrigation system.
Mm-hmm.